Awesome. Oh, hello everyone. My name is James Lee. I'm currently leading developer expert at 12 Labs. So this is the Multimodal Weekly webinar series hosted by our company. We've been meeting every Friday, over the past 7 or 8 months. And as the title of the series suggests, we love to discuss all things around multimodal AI and to some extent foundation models. So we have speakers talking about the cutting edge research of this field. We have, people, developers specifically, as well as staff founders, give talks around innovative, application of multimodal in different verticals. Since we focus more on the video side of things, we also have video-centric companies and practitioner give talks around that area. And finally, we also sometimes invite our internal team members, give tutorials and guides on our technology, our platform, and our API. Over the past few weeks, we have a wide range of external speakers, right, ranging from researchers working at the cutting edge of Vision Transformer, Vision Mamba, text-to-video model, to folks working in industry, from multimodal vector databases to people building technologies in video editing and computer vision. Today, we would love to have some of our internal team member give a presentation about our latest, model and product offerings called Marengo-2.6. So this is a new state-of-the-art video foundation models for any-to-any retrieval. And the presentation will be broken down into 2 sessions. In the first half of the webinar, we'll have Jeff Kim and Marsar, who are the 2 research scientists that did the modeling work for Marengo-2.6. They will cover all the, architecture overview, training, as well as quantitative benchmarks and qualitative results of Marengo-2.6. And then in the second half of the session, we'll have Travis. Sunny's supposed to be here, but I think she's busy with some other work. So we'll have Travis, our founding solution engineer, who will give more the practical demo of what's the downstream task of what Marengo can power, namely our video search API. So with that, for the audience attended, feel free to send your question on Zoom chat, and I can surface that to the speakers as they go over it. And we also have a short Q&A, probably like 5 minutes after each of the part finish. So with that, I will stop sharing my screen. And yeah, Mars and Jeff, you guys want to go ahead and go ahead with your portion.
Okay, sure. Thanks for the introduction. Yeah, let me share my screen. Yep. Okay, so what happened? Yeah. Can you see the screen? Okay, so let's start. Yep. Yeah, let's start. So hello guys, and thank you for joining the webinar. Today's session is about our brand new project, Marengo 2.6. This work was done by Aiden, Daniel, Jay, Jeff, and Mars, and all the 12 Labs teams. And I'm the Jeff. Yeah, yeah, it's good to meet you. And good afternoon in San Francisco, and it's good morning in Seoul. Yeah, and yeah, let's begin. Long story short, these are the introduction of the Marengo 2.6. The Marengo 2.6 is the video foundation model. That means that our model can be used as multiple video-related applications. For example, like classification or the video action temporal reasoning. But here, I will more concentrate on the multimodal embedding capabilities, for example, search and retrieval. Going from 2.5 to 2.6, we try to train larger model with massive and diverse dataset. Also, we made model to support multimodalities. The result of the effort, our Marengo 2.6 yield the state-of-the-art performance on zero-shot text-to-video, text-to-image, and text-to-audio retrieval tasks. And also, we found emergent alignment among the other domains, for example, audio to video and image to video, making it a versatile tool for a wide range of applications. And here is an image depicts overall architecture, gated modality experts. While our model now support multimodality, inputs including image, video, and audio are acceptable. Then the image and video input feeds into the visual expert, capturing appearance, motion, and temporal changes. Also, the audio input processed in audio expert, capturing both verbal and non-verbal audio signals. And finally, we use gated fusion model to merge the features into unified multimodal representation. And finally, that multimodal video representation will be synced to the text embedding. For training, we use 60 million videos with both visual and auditory information extracted. Also, here we utilize our video to text API, Pegasus 1, to generate more fine-grained caption. And in addition to it, we use 500 million images and 500K sounds, including both general non-verbal sounds and music genre. And thanks to these improvements, the model sets a new state-of-art performance records across all text to any retrieval datasets, surpassing existing baselines by a considerable margin. So these are the baseline models we consider. First, we use data filtering network. This is an open source image foundation model by Apple and the University of Washington. And second, we use LanguageBind, which is the open source video foundation model, process both audio and visual information by Peking University. Third, Video Prism is the video foundation model by Google. And finally, we also compare our model with Google Commercial Gemini multimodal embedding API. And this is the table for zero-shot video retrieval. So we use a commonly used benchmark, MSR-VTT, and ActivityNet. The results show that our model achieved the better score than baselines. Also, this is a table for zero-shot image retrieval on Coco and Flickr 30K. While our model is a video foundation model, we achieve better result than image foundation baseline. Finally, this shows the result of the zero-shot audio retrieval on Clozo and Audio Caps, where our model scores the best results. Yeah, I think the former part was about the just spec of our model and some like tables, and I think the fun part start from now. Yeah. So here I'm going to share some qualitative result of our model. So especially we're talking about the such domain. Yeah, so I'm going to share some such result on various domains. And the left side in the table shows the search query we use, and the right side shows the top 2 results from the video database. And yeah, let's begin. Oh, yeah. From the wait a minute. From the start, James, can you confirm me that if you can hear the sound or not?
I cannot hear right now. I think you have to reshare the screen.
Okay, then I'm going to reshare the screen. Sorry about it.
And when you share the screen, make sure to click the share sound option.
Oh yeah. How about now?
Yep, I can hear it now.
Okay, thank you. Yeah. Okay, so yeah. So this is a search result. So we are not generating video, and we are just we show the like a top 2 retrieval result from the video database. And this one we use a sample as from the MSRVTT dataset. And the left side in yeah, let's begin. So the first example is about the mixing food in a mixing bowl. And as you can see here, our video successfully retrieved the right video. I think this one might be a controversial, but it seems like adding like a flour into some kind of sauce. And then the second one is more complicated example. It's about you need to like retrieve a younger, and also the younger need to petting a dog, and also the dog should be laying on the couch. So it's more complicated query. And as you can see here, our model successfully retrieved the right moment in the video. Yeah. And the second one is the like a near miss case, because and there is like a dog and a couch and a petting, but it's not a car, right? But yeah. And the second one is in a NFL domain. So the first query is about Seattle Seahawks player throw to another player, result touchdown. So in here, the model need to find the 3 dynamics. So you need to find the Seattle Seahawks, and you need to find the like a player throwing to another player, and it should be result in touchdown. And let me show you the result. I know it might be, yeah. So as you can see here, the Seattle Seahawks player throw the ball into the same player, and then it result a touchdown. Also, this one is the same.
It's just
And-
learning to transfer.
Uh-huh. Is that was a question? No. Yeah, I'll just go forward. Yeah, as you can see here, you can see our model successfully retrieve the right moment. And the second one is about the Viking player tackle the Jets. And as you can see here, the model successfully retrieved the right team. So the model should pick the moment between the Vikings and Jet. As you can see here, you can see, I know it's a little bit blurred here, but yeah, you can see the Jet Viking player make Jet player fall down. Yep. And next is the qualitative result on a text to image. And the first query is about the child holding a flower umbrella and petting a yak. And this is somewhat similar to the second example in a T2B, which including like a complicated queries. Yeah. And as you can see here, our model successfully retrieved the top 1 image. The second one is about the color, a yellow and blue fire hydrant. So there is a lot of hydrant images in this data set. And as you can see here, our model successfully find out the hydrant with the yellow and blue color. Yep. Also, our model is excellent at the audio retrieval. So the query here is a right lane had continuously fall on the tent. So yeah, as you can hear, this is like a rain sounds hitting on some kind of fabric. And also this one is a rain sound. Yeah, and the second one is about the group of kids playing together and cheer. So yeah. As you can hear, children's sounds and like a cheering in the top 2 moments. Yeah, so here I'm going to talk about the video to video moments. And also like in this query, I'm going to explain the query video first. So video to video is you need to find the most similar video from the given video query. So in this video, let's see. So the pencil player tried to pass, but there was an interception in the video. So what will you think the model should retrieve? So as you can see here, our model retrieved as you see here, there is a same team here. So all two teams are same. And then also, wait a minute, why the full screen is not working? Okay. But as you can see here, the sensor team is trying to pass, and there was the intersection happened here too. And also here, the team is different, but the interception is happened here. So as you can see here, our model successfully retrieved the similar video regards of teams and the main event happened in this video. Also, for this example, the query video here is about the interaction between the animal and the people, especially especially the animal attacking human, right? Yeah, this is somewhat funny video. And here, our model successfully retrieved the right video. So in this video, it's also about the animal attacking human. Okay. And this one is actually a near miss case, and it's not attacking, but you can see that it's somewhat similar by like human near to the animal's head. Yeah. So like this, our model like successfully retrieved the interaction between the animal and the people in a top ranks. Yeah. From here, I'm going to show you some emergent alignment between our model. So we actually do not explicitly train between the image and video for now, and also the audio to video, but we found that the emergent alignment are there, and we found some pretty interesting examples. So here, the query image is about the bathroom, and as you can see here, this is like a video in the bathroom, women in the bathroom. So you can see that even though the bathroom was like a background, the our model successfully retrieved the right video. And also this one is also the interesting moments. And this is the domain is somewhat different, but yeah, this is like a bathroom in the game scene, but our model successfully understand the game environment. Yeah. And this one is about the retrieval the specific character. This is from like a website. And yeah, as you can see here, I know this is not the right Iron Man, but yeah, our model find out the Iron Man. And also in here, you can see the Iron Man. Yeah. So it's all about the video, but our model successfully found the right video, even though it includes a small portion of the seconds here. So as you can see here, the image to video can be used in a large domain, and yeah, we are trying to like do more like quantitative research on this kind of works. And here is the like a audio to video search. So in here, we only use the visual aspect of the in the video. So this is ship sound. And as you can see here, our model successfully find the ship appearance in regard to the ship sound. This one is about also the ship. And this is the violin sound. And yeah, our model. So yeah, this is all about the people playing a violin. So as you can see here, our model successfully understand what is the violin sound and align them into the same embedding space. Yeah. And we also do some also we do some experiment result on a compositional retrieval. So this is somewhat experimental, and we have a lots of things to do on this task. But yeah, so what is the compositional retrieval? So compositional retrieval is the retrieval task that model need to retrieve the right image regard to the both given image and text query. So yeah, from in this example, the model need to find the car, the similar car with the orange color, right? And so where you can use this, uh, we can think about the one scenario. The user tried to search some kind of like a product or the image, and then when user now wants to like in this example, if the user just want to find the car with the like a different color or some kind of slightly different, then it will be better to just write like a with orange color, not to depict all the image in the one text, hold in one whole query, right? So it can be used in that kind of like a interacting scenario. So as you can see here, in this example, we show the like a two rows to compare the what we will change. So this first row is about the image to image retriever. So without the text, our model retrieve those two image, and on the top is the similar to the query image. But after adding like a text query in the like with orange color, then our model successfully retrieved the uh, car with the orange color, right? So yeah, this is the another example of the composition retrieval, and where the query is like a giraffe image, and if you do the image to image search, the giraffe all image will just including the giraffe, right? But if you want some image of the giraffe with like a car, then you can just add like a with car. Then our model successfully retrieved the giraffe image with car on a rank 1. So you can like you can imagine the changing like a attribute, and you can also add like a object, and it will diverse the user's search experience more better. And also we try to do some experiment on the composition retrieval, not only text, but also the audio. So in this in this example, there is like a bike, and we add like an engine sound like this. Yeah, and then our model successfully retrieved the image of the motorcycle, right? So this, yeah, so we know that the bike ending to the engine is the motorcycle, right? Yeah. Also, this one is about the siren sound. So there is a car and like a siren sound. And then the model successfully retrieved it's about the like an ambulance or the police car. And interestingly, I tried to like switch the image into the motorcycle. Then the model retrieved the photo of the police motorcycle. So not the ambulance anymore. So I think this examples are interesting. Yeah. Yeah. So these are the like end of my presentation. And is there any questions?
Awesome. Thanks a lot, Jeb, for the excellent, demo and go over both the model overview, but this very wide-ranging and interesting qualitative results from Marengo 2.6. A lot of interesting use cases. I'm sure that we can think of. So there's already 2 questions on the, or actually 3 questions now on the chat. First one is what's the token size limit, and how does it transfer into typical video clip max length?
What are you talking about the token size limit? Is this in like a video side? So yeah, our model, our base model is somewhat target to the like a small token clip level. So as you can see here is the video, the retrieve video are like 10, like 4 to like 15 minute. I mean the seconds. So our like video clip max and yeah. So it's like a 5 to 15-second video clip that we are currently targeting. Yeah.
Aldo, does it answer your question?
Yeah, it does. I just want to roughly understand if I have a long video, what are the chunks? Like, how is it split? If I want to then later index that.
Yep.
Great.
Thank you.
Awesome. And then Rahul got two questions. The first one is, what's the smallest amount of data that makes training a model like this feasible?
So this is actually the foundation model. So you need like, I think you need at least like a 10 million
Gotcha.
for video text there. And there is actually the open web video data set, which comprise of the 10 million data set. So if you are interested in, you can try to start from there.
Perfect. And then the second question, I guess this two-part. He asked, what's the longest piece of video the model can ingest at once? How do you deal with longer videos than what the model can process?
Oh yeah, I think this one is similar to the first question. And yeah, we are now currently processing a 5 to 15-second video and the first, and we deal it by split the videos and aggregate into another layer.
Okay, then Gasper got a question. When you have an extremely long clip, let's say something from an unscripted reality show or a video podcast, how does your model perform on clips with long run times?
Yeah, this will the model will broke if you just add the long video into like in one input. So we need like a hierarchy run for that. So yeah, I think this is same as the previous question. So yeah, we need to like a chunk into the smaller one and use another like aggregation layer on top of it.
Perfect. Then Miran got a question here. How about the length of a video as a search query? Does it also have to be 15 to 20 seconds?
Yeah, it would be nice to be 15 to 20 seconds, especially query, because yeah, it will be like a if we inject we can split the video query, but yeah, it will be nice if you can just use one query embedding for the video inputs. But yeah, it depends on our like architecture design.
Right. Aldo does have another question here. Do you expect the K-shot accuracy to improve? Say I have 5 to 10 examples of a touchdown and I get an average embeddings for those. Do you expect the results to improve?
If the video, so yeah, we need to like do the experiment for that. So if the video embedding is good enough, you can like you should get the right yeah, you should get the improved result. But if the model itself was not know about the touchdown or not know about the not focusing about that kind of actions, then the model might be not, so like, for example, if you like train for like a color, and if you like add some people action domain for the like a zero shot video to video retrieval, then it will fail. So yeah, it's somewhat is more related to the model's capability. And yeah, and here actually our model are like our model learns about the NFL terminology. So if you add some kind of touchdown, then the model will do the model will improve.
Perfect. Casper, got another question here. Did this model only run in the cloud? What about running on-premise? So this one, I think Travis can cover in the second half of the webinar here, because that focus a bit more on the deployment side of things.
Yeah.
Yeah. Any other question from the audience? There's a lot already. I think that's really cool that you guys engaged and have a bunch of good insights here.
Hi, sorry, can I ask one more follow-up question?
Please.
Firstly, thank you for sharing. This is really cool work. I was wondering if, say you have two videos that are, sorry, one video that's 30 seconds long, and the model chunks it into two chunks, right? The first chunk is seconds 0 to 15. The second chunk is 16 to 30. But the moment that you're looking for is from seconds 14 to 16. At query time, do you do any kind of logic to say that the moment is happening exactly from this time to this time in chunk 1 and chunk 2, or is it just like these two chunks are the most likely chunks to have the query that you're looking for?
So for now, so are you talking about the like a more fine-grained temporal moment retrieval? Then
yeah, that's exactly right.
Yeah, then we actually plan to we are actually developing like a re-ranker model, which can do that kind of stuff on top of our like search model. So yeah, so we need that kind of like an extra additional model to do that.
I see. Okay, thank you.
Thank you. Yep.
Perfect.
Yeah.
Can I ask one more question, please?
Yeah, go for it.
So it's really cool that you guys tried experiments with compositional retrieval. I'm wondering if this kind of enables essentially prompting, where the text portion in the compositional retrieval I can customize and I can try to tune. For example, if I want to use Marengo for a specific task, right? Identifying specific events in a large video and then retrieving them. And then maybe the one shot, the top 1 accuracy is good, maybe top 5 accuracy is acceptable, but I want to improve it. Would you suggest that maybe text prompting is something that I can do, or I have to revert to fine-tuning and adding to the data set and then adding to the fundamental foundational model understanding? Or do you see any improvements in just prompting in the text portion?
Oh, that's a really good question. And I think it's depending on the like I think it's more related into the cost side, because if we need like a prompting or something, we need to like use a large language model for the query and the composition side. But currently I'm just planning in current we can do that in future, but currently I'm planning just using like a smaller model that understand the query, but I think that's a really good that's a really good target our model should be. Thank you for that.
Awesome. Any last minute question from the audience? Tom, I saw you unmute. Do you want to go ahead? Okay. If not, then yeah, feel free to just put on the chat and Jack can answer asynchronously. Awesome. Thanks, Jack, for that great technical overview of the modeling architecture and very impressive quantitative as well as qualitative results of Marengo 2.6, and excited to see future development of our model. And with that, Travis, do you want to go ahead and start with the practical demo of how Marengo can be used for end users on a platform?
Yeah, absolutely. So I'll share my screen really quickly. Can everybody see my screen okay?
Yes.
Okay, perfect. So like James said, I'll show some of the demos actually occurring within the platform. I think, you know, the Mars and Jeff did a great job covering sort of what are the new capabilities that are added because of the hard work the team has done on Marengo-2.6, and I sort of want to show that in the actual playground environment. Some of the other things that they mentioned with the any-to-any modality search will become available a little bit later in the playground, as well as the API. But I do want to touch on some of the core things like increased sports knowledge and description of human subjects and things like that. So I have a couple queries here that I wanted to show. The first one here is it seems pretty basic, but is actually quite interesting. So touchdown seems like it should be pretty obvious, but I purposely indexed some, let's say, content that is not so obvious that it's a touchdown right away the first time you watch it. So I'll play this top result here and see if you can catch it, what happens here on the first play. So they play it back in slow-mo here, and hopefully you can see this. So the ball actually bounces off of this individual's hands here, and then the receiver catches it at this point, and then we see the referee sort of make the touchdown sign there on the far right. So this is a non-obvious touchdown because there's actually a lot of complexity going on in the play here. But despite that complexity, the model has a very fundamental conceptual level understanding of touchdown, so it's still able to map that. Now having that very deep understanding of touchdown in the context of American football, we can look for things that were traditionally impossible in Marengo, plus the complexity of the sports terminology. So for example, with this query, I'm looking for an unusual touchdown from Kansas City. And if we sort of watch this, it becomes immediately evident why it's sort of unusual here. So we have this almost like, basketball lob shot pass here that's thrown up for a touchdown. So this isn't something that you would typically see in the NFL, especially from this player here. So it is quite unusual in this case. And even though, we're operating in this index where I have some videos that are quite long, which I know were questions that came up earlier, on the product facing side, right, there's no issue sort of managing a 20-minute video in the playground environment and being able to execute these search queries, even against a content where we have a noise, let's call it, right? So we have some car footage here. We have footage from the NBA and NHL as well too. Some of the other examples we can show are things like a sort of understanding of other sports. So hockey is also one that we added in, which is very useful. So here, if we search hockey goalie impressive consecutive saves, not only do we sort of need to understand, right, the save, but we want the order of events. So if I play this top result here, you'll see that it's pretty insane, actually. The goalie is able to block, I think, 3 or 4 attempts from this set of players here. So that's the third one, and then the fourth one gets blocked here as well too, as he sits on it. So we can also search for this from a different perspective entirely. So this is really illustrating that Marengo, really understands what it means to have a save in hockey. So this is from the top-down view now, right? So this is on the same index again, but now I'm looking at the top-down sort of results. And if I watch this here, this one is actually more impressive from this angle. So there's a bounce off here because it clips the stick, and then he reaches back and barely grabs before it goes in. And then actually the second result here is that same result that we saw in the original query, but from the top-down angle. So Marengo is very, very clearly mapping the understanding of save here to what we're actually seeing in the content library. I can show a couple examples of non-sports related things where we're looking at sort of shot types and descriptions that are linked to the object that we're interested in. So again, in the same index, if I search for a close-up shot of a red car, here you can see we get exactly what we're looking for in this case. But I can be more specific because we've Jeff and the team have increased the performance of Marengo for the descriptive side of things when we want to add a bunch of adjectives essentially to what we're looking for. So now I can search for a close-up of a red RX-7, And you'll see here, I've intentionally disabled all of the other modalities besides visual to focus in on the fact that Marengo has this deeper understanding of linking adjectives to the target entity that we're interested in. So if I play this here, we have the red RX7, which is a close up here. We're cutting around it multiple times to take a look at it. The same concept also sort of applies to people as well too. So if I want to look for a person doing something specific while wearing something specific, we can do that. So in this case, I have, woman wearing a black and white bucket hat and a swimsuit dancing. So this top result here is actually exactly what we're looking for. And again, you'll notice this is a 20-minute video. So from the product facing side, handling longer videos all the way up to 2 hours and inside the playground environment. To illustrate the fact that we're not sort of just honing in on one individual aspect of the query, and Marengo actually understands these adjectives as they're linked to the entity altogether. I have a query here that sort of differentiates a man wearing stripes in general, where we get this top result of just people with striped sunglasses on, striped belt, jacket, things like that, and then being much more specific. So now I'm going to say man wearing a lot of striped clothing, and with jeans and a black hat. So now you'll see the search results are totally different. And just to really illustrate, we're on the same index here. This is the same content that we've been looking at this entire time. Now if I play this top result, you'll notice, right, we have he's fully striped out, the car, everything, his belt, his shirt, his overshirt, and then of course he has the jeans and the black hat on. And you'll notice that was notably different from just the generic man wearing stripes search, where we added all these adjectives to a single entity that we needed to find within the footage. And then really going beyond that, what if we want to do all of this sort of temporally? So now not only do I want to, combine all of these adjectives that are linked to an individual entity, but now there may be other entities in the scene. And then I also want to add a temporal element. So here I'm going to search for, and here it is, a man wearing a navy jacket and yellow patterned pants sitting with his friends before dancing in a sunset. So this is sort of getting arbitrarily complex on purpose to really illustrate the fact that, right, Marengo is really learning these concepts, and we're not just sort of locking onto one point of the query here. So if I play this top result again from that 20-minute segment, we'll have the man and the navy jacket with the patterned pants sort of dancing in the sunset. And you'll notice that order is correct, right? So first he's sitting with his friends and then dancing in the sunset. And so we have the individual entities, his friends, we have the man with the adjectives that should be attached to him. And so his friends aren't the one, wearing the navy jacket or the patterned pants. It's clearly linked to him. His friends are separate, and then dancing in the sunset is a temporal part of the query here. And just to really sort of illustrate, right, that again, we're not locking on to one part of the query. I have one here that's a slight variation. So a man wearing a navy shirt and yellow pants, standing with his friends, right? So now we've slightly changed it, and you'll see the search results are totally different now. So if I play this top result, we have on the right-hand side here, right, in the navy shirt here with the yellow pants, standing with his friends this time. So again, all on that same content library with all that noise, but able to map the adjectives to the entity in this situation. And of course, all the performance increases on the world knowledge side in terms of sports and things like that, without forgetting any of the previously learned important aspects like the temporal portions of queries and things like that. This is, sort of what you'll experience today as the enhancement from just having Marengo-2.6. And then, of course, all the really, really cool stuff with the any-to-any search modalities and compositional any-to-any search modalities will be coming very soon, both sort of on the playground side and API side. But I just wanted to sort of give a practical look at what you can expect to experience as a difference within the playground and product in general as you use Marengo-2.6 for your use cases going forward. So I'll stop there and see if there are any questions.
Awesome. Thanks, Travis. Thanks for painting a vivid picture of the key capabilities of Marengo and what our users can achieve on the playground. Perfect. Let's see. Gasper, I saw you raise your hand. You just want to ask your question?
Yeah, I do have, by the way, I love the technology. I think it's great. I'm a video editor now in Hollywood, but before that, I did a lot of assistant editing, and media asset management is one of the main things that we do. And one thing I was wondering is there any way that we could inject our own metadata? You know, like let's say, for example, I import a bunch of footage in a program like Avid. I could inject my own metadata into that. And is there a way maybe for your models to look at some of the metadata that we inject, you know, on-prem into this model? Like, so the model could, you know, look at some granular things. For example, I'll give you a use case. I'm on American Idol right now, and Katy Perry, Luke Bryant, Lionel Richie, they're individuals that are on there. Now, obviously, we could train probably what their face looks like, but I could also just inject that information manually. Is that something that your models will be able to do at some point in the future, if not now?
Yeah, so I'll answer it in two ways. One, how you could do it today if you go to the playground or use the APIs, not the playground, but the APIs. When you create a indexing task for a video asset, you have the option to add custom metadata to that video asset, and you can perform filtering functions right on that custom metadata. So you could say, you know, one of the judges is yelling, and then you would have filtered by Katy Perry, for example. The model probably already knows Katy Perry because it's they're a celebrity, but let's say it's somebody right that's lesser known, or one of the contestants that's metadata on that. You can filter on that metadata after the fact. The other thing to think about is with the addition of the any-to-any search modalities, you could always just provide right an example of that individual's face or something like that. If you don't have the metadata at hand that you wish you had for fulfilling that request. And with the compositional query, right, you could say, here's a picture of that judge. I want you to find them, right, like yelling or getting up and dancing or whatever it may be. But in general, we can also associate metadata with the assets and filter on them. And
Awesome,
eventually that will
thanks.
become part of the semantic search as well, too. So that is a direction that we're moving.
Awesome. Thank you.
Of course.
Great. Yeah, any other question from the audience? Alda?
Yes, hi. So I already asked a similar question, but I just want to double down on if I would, I mean, this is really awesome, guys, like really impressive. So kudos on a great job issuing this model. I really want to use it. So, and if I want to use it for some applications and I want to improve the accuracy, right? So like today, I want to say, okay, not just top 1, top 2 results, like what tools do I have in my disposal to try and improve the accuracy? Looks like Travis already suggested maybe providing video examples in this kind of multimodal search, but also like what are all the tools that I can have with the current model to try to improve the retrieval accuracy for not just the top 1, but say top 5, top 10, top 20.
Yeah, so I'll start with the easiest one, which is really query engineering, or prompt engineering as they call it in the LLM land. And that, for me, the way that I typically approach that is whatever I'm interested in finding, I will generalize it as much as possible, right? So some reduction to a very high level sort of description of what it is, right? So, touchdown is a good example, right? I just want to find touchdown. So the first thing I'll do with the model is query touchdown and get that top level result pool to see, right, is the model even understanding that terminology correctly? Because if it's not understanding the general terminology, it's probably not going to understand the more complex situation you're looking for. And you may have to sort of reword that general description. Once you have that initial search pool, then I would recommend starting to add on the modifiers, whether they be adjectives or temporal modifiers in succession to narrow down that search pool iteratively until you sort of get a refinement. You can also make the thresholding more strict as well too. So you can make it so that the model has to be exceedingly confident for it to be a high confidence score and filter out right by the high confidence level. So that will restrict sort of what ends up in the general results anyway. That's sort of the easiest way to do it because it's just basically either modifying the query or the API parameters. The other things that we have coming that we will be sort of making available. So one of them, right, is the any-to-any search modality. We talked about that. There will also be eventually a fine-tune API that's made generally available to the public. We're working with a lot of our customers right now to figure out what that API should look like for a really good user experience. So we're working with customers right now to figure out things like not just the API endpoint design, but how do we also recommend the way in which you construct that fine-tuned data set, for example, so that you have that model for your particular use case. So those would sort of be the things that I would lay out as, from easiest to what you'll have to wait for, but hopefully you find that helpful.
Thanks a lot, Travis.
Yep.
Awesome. Yeah, thanks for the question, Adam. Let's see.
Oh, we had a question that we wanted to cover from earlier about only running in the cloud or on-premise. So we do have customers that are running the deployment either in their environment fully or sort of hybridized. So there are cases where you might not want to manage all of the infrastructure, especially the GPU side on-premise, and you may want to sort of do like this hybrid deployment between on-prem and in cloud. But in general, we are flexible with sort of the deployment strategy when engaging with customers.
Yep. Hope that answers your question, Casper. Yeah, I didn't see any other question in the chat. Does anyone have like any real-time question? We still have like about 5 minutes left for this session. Yeah, well, if there is no other question, I think maybe we can end a bit early, give like 5 minutes of people time. And I think really enjoyed the session, Jeff and Travis, for providing like an excellent coverage of scientific capabilities of Marengo 2.6, as well as practical application of what can be achieved on our platform. Yeah, excited for all of you, our users, to play around with the new model on our search API, and which is already available on the playground. And good luck to get some feedback as you play around with it, and give us some more ideas on how to improve the next version of the model, as well as the interface. Next week, at the same time, we'll have another session that cover the other foundation model that we'll have called Pegasus One, and very similar format to this one. We'll have the scientist team and the product team cover the modeling, as well as the application aspect of that model. So yeah, if you found a lot of good insights from the session, feel free to sign up and attend that one next week. Awesome, guys. Appreciate your attention, your attendance, and enjoy the rest of your weekend. Bye-bye.